Let's find the sum of this arithmetic series. We see the first term, t1, is 11. And notice how the numbers are going down by 3. So the common difference is -3. Now the key idea here is to look at the last term, tn, which is -100. Recall the formula, tn equals t1 plus n minus 1d. And let's substitute -100 into tn. -100 equals the first term, 11, plus n minus 1d, which is -3. We can now solve for n. Let's throw 11 to the left. We have -111 equals, using distribution, we have -3n plus 3. We'll move 3n to the left here. This becomes positive 3n. And we move -111 to the right. It becomes positive 111. Plus 3 is 114. We divide by 3 to solve for n. 114 divided by 3 is 38. So n equals 38. We can now use the Sn formula, which is n over 2, t1 plus tn. N happens to be 38. So the sum of 38 terms is 38 divided by 2, t1 plus tn. t1 is 11, and tn is -100. Using a calculator, we see that the sum is -1,691. Let's find the sum of the odd numbers between 100 and 1,000. The first odd number is 101, and we keep on adding 2 for more odd numbers. So when we're adding these numbers, 101 plus 103 plus 105, etc., we eventually reach the last odd number, which is 999. We now use the formula Sn equals n over 2, t1 plus tn. We have t1 here, and we have tn here, the first and last numbers. But we don't know what n is, so let's use the other formula. Tn equals t1 plus n minus 1d. The last term is 999 equals the first term, which is 101, plus n minus 1d, which is positive 2. We keep increasing by 2. So 999 minus 101 is 898 equals, using distribution, we have 2n minus 2. We throw the -2 over, so we have 898 plus 2 is 900 equals 2n. Dividing both sides by 2, we have n equals 450. We now have n. So S, the sum of 450 terms, is 450 divided by 2, t1, which is 101, plus tn, which is 999. Using a calculator, the sum is 247,500. Let's find the sum of the multiples of 3 between 100 and 200. What is the first multiple of 3 after 100? We can either guess or use long division. Let's use long division. 3 times 3 is 9. We subtract. 3 times 3 is 9. So we see the remainder is 1. 100 divided by 3 is 33 and 1/3, the remainder over the divisor. So we multiply 3 times 33 is just under 100. So let's add one more. So 99 plus 3 is 102, and this happens to be our first number. That's a multiple of 3. So let's list these numbers. 102 plus 105 plus 108, and we keep on adding 3. Now the question is, what is the last number that's a multiple of 3? We can either use mental math and guess, or again we can use long division. What is 200 divided by 3? 3 times 6 is 18. Subtract, we get 20. 3 times 6 is 18, and the remainder is 2. 3 times 66 is 198, which is perfect. It is a multiple of 3 and is below 200. So the last multiple of 3 is 198. Let's use the Tn formula to find out how many terms there are. Tn equals T1 plus n minus 1 d. The last term Tn is 198. The first term T1 is 102. And n is what we're trying to solve for. D is plus 3. 198 minus 102 is 96. And we use distribution here and here. We have 3n minus 3. We throw negative 3 over, so we have 99 equals 3n. Dividing both sides by 3, n equals 33. We finally find the sum of 33 terms, which is n over 2, 33 over 2, T1 plus Tn. T1 is 102, and Tn is 198. Using your calculator, the sum is 4950.